All right, we're still working on units. All right, let's do number 1. You are given 2 pieces of information: the volume of a lake in cubic feet, feet cubed, and the average depth of the lake in feet. You are asked to find the surface area of the lake in square feet. You would take the volume and divide by the depth, and that would give you the feet to the second power. So this is to the third, this is to the first. You subtract the powers and you get feet squared. So you would divide the volume by the depth, because this will cancel the depth and the volume and give the feet, give feet square in the numerator, which are the units of surface area. What are the basic metric units for length, mass, time, and volume? The basic metric units for length, mass, time, and volume are, metric units are in meters. So meters for length, kilograms for mass, seconds for time, and liters for volume. Okay. Okay. Decide whether the following statement makes sense, or is clearly true, or does not make sense, clearly false. I drank 1 liter of water today. Well, let's put liters in gallons. How many liters are in a gallon? Liters to gallons. 1 liter is about 0.26 liquid gallons. So a quarter of a gallon should be okay. So that's about, so the statement does make sense. 1 gallon is 0.26, or in this case, it's going to be 0.3, because I think they want you to round to 1 decimal place. My car's gas tank holds 13 meters of gasoline. This makes no sense. This should be something like gallons. Meters is not a way of measuring something that's in volume. What's your average speed in miles per hour? Okay, let's do this one on another page. What's your average speed in miles per hour? So we're looking for miles per hour. If you travel 1 mile in 15 minutes. Okay. So your average speed in miles per hour is this. So you would drive 1 mile in 15 minutes. So we want to switch a miles per minute. So 1 mile every 15 minutes. We're going to try and switch it to miles per hour. So in order to do that, we're going to need to cancel out minutes. So we'll put minutes up here. And we need to put hours down here, and we know that 60 minutes is 1 hour. So this will take us and put us in miles per hour. The minutes cancel, and you're left with 1 over 15 times 60 miles per hour, which is what we want. 60 divided by 15 is 4 miles per hour. Let's do feet per second. So I got 1 over 15 miles per minute. And I want to change this to feet per second. All right, so I got to get rid of, let's get rid of minutes first. So I need to put minutes up here, right? So 1 minute is 60 seconds. And I want to get rid of miles too. So here's miles down here, and I need feet up here. And 1 foot, 1 mile is 5,280 feet. 5,280 feet. And so we're doing, so then now we have the correct units. The miles cancel, the minutes cancel. So we have 1 over 15 times 5,280 over 60. So we've got 5,280 divided by 60 divided by 15. 5.8 something. Let's see, round to the nearest tenth. 5.9. It's approximately 5.9 feet per second. Decide which of the two given prices is the better deal and explain why. So the better price, we're talking about dollars per ounce. So the first one is $2.49 for a 6 ounce, or $11.29 for 15 ounces. And we'll just do the calculation. $2.49 into 6 ounces is 0.415, and it's dollars per ounce. And then we're doing $11.29 divided by 15 is 0.7526. 3, and that is dollars per ounce. And so this is the better deal. So the 6 ounce is the better deal, and then we'll put, and then you just need to round to the nearest cent. So 0.42 per ounce, and the 15 ounce is 0.75 per ounce. Decide which of the two givens is the better price, better deal, and explain why. So we're still talking about dollars per gallon. So the second one is already done. It's $3.10 per gallon, per 1 gallon. So the question now is $50.46 over 15. Again, dollars per gallon. So we'll put that in. $50.46 divided by 15. $3.36, and so this one is the better deal, and we'll put $3.36. Here we're just going to use some notation. Usually we don't even use these types of meters, but mega means 10 to the 6th. So a megameter is 10 to the 6th times as large as a meter. So that's a 6. Just looking at the table. A liter is, so a nanoliter is 10 to the minus 9th of a regular liter. So the liter is 10 to the 9th times as large. A gigameter is 10 to the, let's do giga, is 10 to the 9th times as large as a meter. A centimeter is a meter, so a centimeter is 10 to the minus 2 times a meter. So a meter is 10 to the 2 times as big as a centimeter. So a gigameter is 10 to the 11th. You add the powers, 9 and 2. A cubic meter is blank times as large as a cubic centimeter. Okay, so we know that a meter is 100 centimeters. So you want to cube both sides. So we'll put a 1 here. And so that means that 1 meter is, well, let's put it this way. This is 10 to the 2nd, right? And so if you raise both sides to the 3rd power, you're multiplying these 2 powers. And so this becomes 10, so 1 meter cubed is 10 to the 6 meters cubed, centimeters cubed. So this is 6. The Greenland ice sheet contains about 3 million cubic kilometers of ice. If completely melted, this would release about 2.7 million cubic kilometers of water. So here you take the 2.7 kilometers cubed and you divide by 341 million and you see what number that is. And this is kilometers squared, and the units will be kilometers. And you just need to do the division. 2.7 divided by 314 is about 0.00. How many decimal places? 3 decimal places, about 0.009. In a certain country, the population was this, and here was the area. In 2000, the population was this, and here was the area. Compute the densities. And so the density is just people per area, right? And so all you're going to do is divide. So we got 76,111, 465 divided by 2923887. And if you didn't know, it is given by this, people per area, and you just calculate these 2 numbers. So then it's all a calculator. In 2000, it was this. And you would do that. And just make sure that you're rounding. And they want the nearest whole number. So you just round to the nearest whole number.